The car is moving with a speed of 45 kilometers per hour without skidding. What is the angular velocity of its wheels in RPM if the radius of the wheel is 26 centimeters? Consider significant digits. Let's see what is given in this problem. The speed of the car, which is the same as the speed of the center of any of the tires, and this is given as 45 kilometers per hour. We also know that the radius of wheel is given as well, and that is equal to 26 centimeters. We are supposed to find the angular velocity of the wheel. Okay, so let us establish a relationship between the angular velocity of the wheel and the speed of the center of the wheel, which I am showing here by O. Let's say this tire is rotating clockwise. That would be in this direction. Then it is obvious that if we wait for a while, the point of contact, which is A, will move away from the ground, and the point of contact will be point B, which will fall on B prime, which is on the ground. Now it is obvious that the distance AB prime would be equal to the arc AB. This is especially correct because there is no skidding involved and all the points are in contact. Now AB prime would be the distance that the center of the wheel moves during this interval of time that we have considered. This is equal to the arc AB, which is equal to the radius of the wheel times the angle wheel rotates, which I'm showing on the sketch by theta. If we divide both sides of this equation by time, we will have AB prime divided by delta t is equal to r times the angle, which is theta, divided by delta t. Now delta t is the time where we waited until the point of contact A was replaced by the point of contact B. AB prime divided by delta t, as we can see from the diagram, is equal to the speed of the wheel, or the same as the speed of the car. So I'm showing that by V. That is equal to r, and theta, which is the angle by which the wheel rotated, divided by delta t, is equal to omega, which is the angular velocity of the wheel. And this is velocity of car Okay, now let's see whether we can calculate the angular velocity from this equation. First of all, let's make sure the units are what we're looking for. The velocity is given as 45 kilometers per hour. This is equivalent to 45. Instead of 1 kilometer, I can write 1000 meters, and instead of 1 hour, I can write 60 minutes. I am keeping minutes because my final unit is going to be RPM, which is revolutions per minute. This is equal to 750 meters per minute. The radius is given as 26 centimeters, but since I have meters in velocity, I'm going to convert this into meters, and that would be 0.26 meters. I could also have converted the meters here into centimeters, but the final answer is not going to be any different. The angular velocity, therefore, is a velocity divided by the radius of the wheel. That's 750 meters per minute divided by 0.26 meters, which is, if you use your calculator, 37,500 divided by 13 radian per minute. As you can see, I am not dividing 37,500 by 13 because that would lead to rounding a number, because I won't be able to keep all the digits of the number. But there is no reason that I do any rounding at this stage. I'll do all the rounding at the very end. Now I need to convert radian per minute into RPM, or rotations or revolutions per minute. We notice that 2 pi radians is equal to 1 revolution. Therefore, 1 radian is equal to 1 over 2 pi revolution. If we sub this into the value we have for omega, we realize that omega is equal to 37,500 over 13 times, instead of 1 radian, now I can put 1 over 2 pi revolution, and instead of minute I can keep minute. If I simplify this, I am going to get 18750 divided by 13 pi revolutions per minute, which is approximately equal to 459.100797 RPM. But I noticed that in this problem I have only 2 significant digits. To make sure, let's go back to the statement of the problem. We can see that the speed of the car is 45 kilometers per hour. That has 2 significant digits, and the radius of the wheel is 26 centimeters, which has again 2 significant digits. So I'm going to keep 2 significant digits in the final answer to this problem, and that would end up 460 RPM. I would keep the first 2 digits, and I would have to cut the 9, but because 9 is closer to 10 rather than 0, I would round 5 up into 6 and leave 9 as 0. In other words, 59 is closer to 60 than 50. Therefore, we keep the number as 460 RPM.